Right, here we go. Here we go. Surface area of pyramids and cones coming up. Let's see here. 14 questions. Copy the measurements given onto the net of each solid. All right. Oh, whoops. You have to start it twice. And doing so. 13 there, 30 there. For the slant height of the cone and for the radius of the base. 20 there. And 26 there for the slant height of the square-based pyramid. Or it looks to be a square-based pyramid. Otherwise known as the apothem, or the altitude of that triangle there. Anyway, 8.9, 21.9, and 13 is fine. Okay, so this, we'll do that, and we'll call that 8, that 12, and that 18. Diameter 16, slant height 23.4. Width of the rectangle 33, height 14. That is 20. No, actually. That should be here. 24. Find the lateral area and surface area of each figure. Round your answers to the nearest tenth if necessary. So, I have Wolfram Alpha open. The lateral surface area will be the area of one of these triangles multiplied by 5. So that would be 8 times 10.6 divided by 2. In other words, 4 times 10.6, which is 42.4. And then times that by 5 to get 212. 212. As for the base, that would be the number of sides, which is 5, times the length of one of the times the apothem, 5.5, times the length of one of the sides, which is 8, and then divide all that by 2. So 20 times 5.5, which is 110. So add that on. So we get 322 square feet. Here, the lateral surface area will be, let's see, okay, so it's an equilateral triangle base. Oh, right, sorry, yeah. We just have to figure out the area of just one of the sides. So 9 times 11.3, which is 101.7, and then multiply that by 3, which is 305.7 square centimeters, and then figure out the area of the base. So that'll be 9 times 7.8 and divide that by 2. So in other words, 9 times 3.9, which is 35.1, I believe. Not right. Hmm. 9 times 7.8. 70.2, and divide that by 2. So 35.1. It is right. 35.1 added to that is 340.8 square centimeters. Next up, hexagon. So 6 times 12.2, divide that by 2, and then times all of that by 6. So in other words, 3 times 12.2, which is 36.6, and then all of that has to be multiplied by 6, so 219.6 square inches. And as for the base, 6 times the upper thumb times the side length, divide all of it by 2. So in other words, 18 times 5.2. So 10.4 times 9. So 93.6. 93.6. Okay. And add on 93.6. And we get that. And now the lateral surface area will be 6.3 multiplied by 4, divide that by 2. So in other words, 6.3 times 2, which is 12.6, but then all of that times by 4. 12.6 times 4 is 50.4. And you have to add on 16, so 66.4 square inches. Here, 11 times 12.5, and then all of that has to be divided by 2, and then you have to multiply that by 5. So let's just do 55 times 12.5, and then divide it all by 2. 55 times 12.5. So it'd be 6875. 687.5. And then all of that has to be divided by 2. 343.75, I think. I've already forgotten it. Oh well. 55 times 12.5. Just do it again. $687.5. 343.75, I think. For the total, we'd have to do, to get the base, 5 times 7.6 times 11, and then all of that divided by 2. So 5 times 3.8 times 11. Come on, in your head. 55 times 3.8. 209, I believe. So add that on. That's just my best try for that. All right, so 11.3, multiply that by 6, so we get 67.8. Then that has to be divided by 2, so 33.9. Then it has to be multiplied by 6. $203.4. 203.4. Now for the base, 6 times 5.2 times 6, and then all of that divided by 2. So in other words, 18 times 5.2. So 46.8, double that, 93.6. And then add that on. A pyramid with slant height 6.8 miles, whose triangular base measures 11 miles on each side. Each altitude of the base measures 9.5 miles. Okay, so $6.8 has to be multiplied by 11 and then divided by 2 to just get one of the lateral faces. So 3.4 multiplied by 11, which is 37.4, and then that has to be tripled to give 112.2 square miles. And then for the total, the altitude of the base is 9.5. Okay, so 9.5 multiplied by 11 and then divided by 2. So 104.5, so 52.25. Then add that on, so 164.25. A rectangular pyramid measuring 4 inches and 9 inches along the base, with slant heights of 10.1 inches and 9.2 inches, respectively. Okay, so the for the two larger triangular faces, we'd have to do just 9 times 10.1. That's all to get the first one. to get the first pair. So 90.9. And then 4 times 9.2, which is 36.8. So 36.8 plus 90.9. 127.7 square inches. And as the base is 36 square inches, just simply add that on. So we're going to get 163.7 square inches. But now we must check everything. Literally everything. Okay, so this is just the first set. I'm already somewhat spent. What a disaster. Well, at least I'm trying. And that's all you can do. Okay, so that's all correct so far. That's correct. That's good. Darn it. That's not. But the gap between them is. Okay, so I like that. So I just have to redo the lateral. Let's see how this one was. Okay, that's correct. That's good. And that one is as well. Okay, I like that. And that one. And that one. Okay, fantastic. Okay. And the last ones are nearly there. This one has to be redone. Okay. Number 8. Trying again. Okay, so 9 times 11.3, 101.7, and that has to be then divided by 2 and multiplied by 3. Oh, that was it. That was it. Okay, so I'm going to divide it. I'm going to multiply by 3 first. So 101.7 multiplied by 3 is 305.1. And then divide that by 2, 305.1, and you will get 152.55. 152.55. But they want it to the nearest tenth, so we'll say that. And then for the total, it's a triangle whose, okay, so 9 multiplied by 7.8 and then divide that by 2. Well, that's the same as 9 times 3.9, which is 35.1, isn't it? 35.1, and then add that on. So 187.7, and we check. Okay, better. That's fixed. The lateral surface area of this has to be fixed. We'll fix the entire thing. Okay, so notice how it says respectively. That was the error. That was the error. All right, so slant heights 10.1 and the base 4. Okay, so 10.1 times 4 is 40.4. And then 9 times 9.2 is 82.8. So 40.4 add 82.8 is 123.2 square inches. And the base is 36. So just adding that on. Now check. Okay, that's all fixed and good. Who's next? Now we will look at nets of solids. Identify each solid given its net. Pentagonal pyramid. That is a cone, though it may not look it. It is a cone. Triangular pyramid. Square-based pyramid. Hexagonal pyramid. Cuboid, although they will likely call it a square-based prism. This one, a rectangular pyramid. And a pentagonal prism. Sketch the net of each solid, label the measurements given. Okay, so roughly speaking, the net of a cone kind of looks a little bit like that. A little bit. 4 and 8.2. That's fine. Multiple nets are possible. I'm just going to draw the most obvious one. Which is the cross shape. And 16, 19, 6. Likewise here. And 16, 8, and 5. Wait. Okay. Square base. Ugh. It's that rectangular prism. They clearly look like squares, but gotta correct it. Rectangular pyramid, pentagonal prism. Yes, that's fine. That's all fine. 9.6, 14, 20.4. That's good. That's good. That's good. And it's sufficient. And now for spheres. Who fears spheres? Not me. Anyway, all right. So I know that the volume is 4/3 of pi r cubed, and the surface area is 4 times its shadow. So here we go. We're going to get it to, decimal time, calculator time. Got it? Pi r squared, so pi by 9, so rather 9 pi and then 36 pi. So about 113.1 square feet. In this case, 6, so 36 pi, quadruple that, 144 pi. $452.4 square centimeters. 15.6, halve it to get 7.8, square it to get 7.8 squared. You know what? If I have to halve it and then square it and then quadruple it, yeah, that would be d over 2 squared by 4, right? It's fine. Yeah, it'll be unstable. Some information about the surface area and volume of two similar solids has been given. Find the missing value. All right, so there. So the it would have to be 125, 200, 125, 512. Three. So over 5, and then so 8 over 125. Okay. Now to check everything. We checked up to there. Okay. That's all in agreement. That's all good. So that's complete. All right. Be well, be well.